So Ken's going to be talking about getting the smarts wrong, how not to build hackable products, like I mentioned at the beginning. So hopefully he's all set up. So over to you, Ken.
Between you and the bar, so I'll go be really quick. Anyway, who am I? Ken Munro, ethical hacker, pen tester, particular interest in IoT, breaking it to make things better. Now, you probably know our very first piece of research into the smart devices, which was the wonderful My Friend Kayla. Show of hands, who knows about My Friend Kayla? Wow, small. Oh, I'll have to do the demo then. Well. My Friend Kayla, interactive talking doll. She is brilliant. She was the first one on the market. She is amazing. She's got a microphone, a speaker, Bluetooth connection. Child can talk to the doll. The doll then sends the audio to your phone, to an app. The app decodes the voice into text. She looks up the answers to questions on a local database or looks up answers on Wikipedia and speaks back to the child. Brilliant idea. Kid can have an interactive kid with a creepy dolly. I love the idea of that. Microphone, speaker, Bluetooth. She's a Bluetooth headset. I kid you not, you can connect her to your phone, and if you really wish to, you can make phone calls on the doll. But you get some very weird looks, particularly when you're driving. But anyway. The hacker in me is looking at this dolly going, I saw the box on the shelf when I bought her. It said, internet safe, child friendly, brilliant. It suggested that they cannot make this doll swear. The hacker is going, this is a red rag to a bull. I want to know if I can make this thing swear like a docker. We reversed engineered the Android app. We took it apart. We found a SQL-like database called ZBadWord, full of 1,536 swear words. We deleted it. She swears. I love this dolly. Anyway, that was fun. The creepy bit is, of course, when you pair a Bluetooth Classic device, typically you're asked for a numeric comparison. So as you would pair your phone to your car kit, you're asked for a 6-digit PIN and to compare them. Great. Fantastic. Sets up a form of security, makes it difficult to intercept. This doll has no pairing security, which means that anyone in Bluetooth range can connect the doll, connect the microphone, spy on you, and talk to your kids. Brilliant. I love that. We put this to the market. People were interested. The German telecommunications regulator, whose name I can't pronounce, said, hang on a minute, are you saying that someone can use a kid's doll to spy on people's audio? Yes. They banned her the next day. It's illegal to own this doll in Germany, which makes it very difficult taking her out there to give a talk. That's another story. She is genuinely on display in the Spy Museum in East Berlin. I love this doll. Anyway, I'm going to start with her. I'm going to finish with her. We'll come back to her in a minute. Anyway, the game changer for IoT is that the device is in the hands of the hacker. Unlike a web app, infrastructure, servers, they're in a data center. You have sold your device to the hacker. Bring it on. What goes wrong? One of my favorite demos, which unfortunately I can't bring along with me because my smart Wi-Fi kettle is actually cable tied to my Christmas tree at the moment. That's a long story. Anyway. A few years ago, you can see it on the BBC website, it's on our blog, we found a Wi-Fi enabled kettle. The idea being, you wake up in the morning, you roll over, you press a button on your mobile phone, and by the time you get to your kitchen, you've got a kettle full of boiling water for your cup of tea, saving you, 30 seconds of your day? Anyway, we looked at this, read the manual, pulled the firmware and realized that actually it was vulnerable to an evil twin attack. You could de-authenticate it, and you could connect to the kettle from the street outside and recover someone's Wi-Fi pre-shared key. Brilliant. I loved that. The manufacturer, we put this to them, they ignored us. But they then launched a version 2 using the ESP8266, which was great, expressive systems, lovely hobbyist chipset. Doesn't offer any secure storage, so it had a bunch of problems. And finally, about 4 years ago, the manufacturer re-platformed onto the Electric Imp platform. Nice, secure environment. Shame they kept getting it wrong along the way. Anyway, I want to talk today a little bit about electric vehicle chargers. Right, who here's got an EV? I've got 2. I absolutely love electric vehicles, but we've been looking at EV charge point security over the last few years. Fascinating area. The idea being with an EV charge point is you can use it to take control of the car's battery and balance the grid. One of the challenges we have with our grid right now, because we're heavily reliant upon renewables, is the power's generated when we don't need it. What if we could use all the EV car batteries in the country to balance the grid? Brilliant idea, except you need to make the charge points smart to do that. And that's where things started going wrong. I'll start with the first one. This is the very first charger we looked at. My colleague Vangelis did that. It's from a company called Project EV. It was manufactured by a Chinese manufacturer called PenTest, and the platform from a company called Shenzhen Growatt. About 3 million devices are sat on that platform. Unfortunately, they made a fatal mistake. They had a complete lack of authorization on any API call that you made from the mobile app. All it looked for was the charger ID, which was sequential and written on the sticker on the side of the charger. So once you had one, you could iterate up or down and find all the chargers and make any request to any charger you wanted, turning it on, off, locking it, or even worse, we also discovered you could remotely flash firmware over the API. You could install your own firmware and turn it into backdoor, so you had a pivot onto your customer's internal network. Brilliant. You could also brick it, and we had full platform admin over the entire platform. Unfortunately, this one actually failed because we had some contactor arcing and it burned out after a few months, so not a good sign. Next place we went, a Spanish manufacturer who's got several 100,000 of these in the market called Wallbox. They had an insecure direct object reference on their API. That meant that we could trivially hijack anyone's account, and we had full control over every charger on the platform. Whoops. The bit that surprised me, though, those of you recognize that bit on the right there, it's a Raspberry Pi compute module. Bit of an issue. Lack of a secure bootloader means you don't have a root of trust, which makes it very, very difficult to fully secure all your communications and data. It's not just chargers, though. We also looked at charging networks. So I have a charging card that allows me to roam over multiple charging networks, which is great. Uses the Open Charge Point interface. Fantastic. We love a bit of that. Unfortunately, one of the largest charge point manufacturers in the US had an exposed GraphQL endpoint, which meant we could access everyone's details, charge for free, or turn people's charging off. Those of you, when you do get round to getting an EV, because they're coming, it's quite irritating when you wake up in the morning and find your car hasn't charged and you haven't got any charge to get you to the station or work or whatever. Bit of a frustration. Next place we went was the EO smart charger. I believe this was the very first smart charger in the UK. Unfortunately, they platformed on the Pi 3, which meant it was trivial to recover the file system from the SD card. This is the best hacking in the world, right? You open it up, take out the SD card. Wow, I'm a hacker, cool. And from that, we could get all the keys, decipher, decrypt all the communications, the whole lot. In fairness, the company was actually quite receptive. They listened to us, we told them, and we didn't disclose this until they'd fixed the bugs. But don't put it on the Pi 3. And they went through a big process. We actually introduced them to a third party who specializes in making stuff like this. They re-platformed onto a Zentree MCU. It was really cool. They did a great job. And then was the Mini Pro, and this has just come to market. This is the Mini Pro 2. It's the smallest form factor charger on the market, and inside, those of you who know your stuff will recognize the Raspberry Pi Zero in there, complete with SD card that you can remove and take everything that assures the root of trust. Use the Wi-Fi keys, credentials, the works. I love the Pi. I use them daily. I have a Pi hole on my network. I absolutely love it. It's an amazing educational prototyping tool. Absolutely fantastic bit of kit. Huge, huge kudos to them. I don't recommend building commercial smart product on them currently with a lack of secure bootloader. Don't think that's a wise idea. There you go. That's the Mini Pro 2. We do weird things. We also hack hot tubs. Random thing we did a few years ago. This is a great example of rushing a product to market and not doing the smarts right. We started looking at the API for this smart hot tub. The idea being is that you could use a mobile app to turn the powerful electric heater on and off. So it was warm when you got home and you didn't waste power heating it during the day when you weren't there. Unfortunately, the authorization to the platform, the authentication were all static creds in the mobile app, which means that everyone had the creds to everyone else's hot tub. The challenge was identifying how it authorizes and identifies to the platform. It was the MAC address. Really? Come on. The problem with the MAC address is if you know your way around Wiggle, wigle.net, the Wireless Integrated Geographic Location Engine, which is a database of war driving where people go around and look for wireless access points with their GPS coordinates, you can recover all the MAC addresses from public sources. You just need to know the SSID format, and you've got the location and IDs of all the devices. Great. So now you can do crazy stuff like take control of people's hot tubs. You can turn the temperature up and down. You can turn the jets on and off. Great. Then we had a really fun episode of BBC Click that we recorded a couple of Christmases ago where we sat in a hot tub getting extremely cold because the heaters weren't very good and explained these vulnerabilities. Why did the hot tub matter? Who cares if I turn the power off to your hot tub? The problem is it uses a platform from a company called Digi. They went to market. They got there quickly by using an existing platform. The problem is it wasn't just hot tubs on that platform. Lots and lots of other manufacturers also used the same platform to get to market faster. We found on there smart medtech. We found cerebral stimulators on the same platform with the same lack of authorization. We found truck telematic units on the same platform with exploitable vulnerabilities. We found cars on the same platform. You've all seen the Jeep hack? That's how it started, in a very similar way. I think I've got this with me, actually. You know what blows my mind is how people forget the basics. Smart door locks. Anyone got a smart door lock? Good. Keep it that way, because every time we start looking at smart door locks, we're like, great, the smarts aren't too bad sometimes, but actually the physical security has gone crazy. This is, it's an ultra lock. Amazing fingerprint door lock, except that what they forgot, they put in a manual key override there. There's enough space to get a pick in, and you can trigger the latch with a pick, trivially. You don't have to pick the lock, you just flick the latch, off it goes. Now, the major problem you have is this one's actually made of case-hardened steel, but a lot of smart locks are made from softer zinc alloys, like this one's using Zamac 3, I think. Melts at about 400 centigrade, easy to cast. We don't make door locks out of soft alloys. We make them out of case-hardened steel, but they're not easy to cast. We just go with this one. I think it's called the Pine World lock, I think. We managed to drill the case in less than 2 seconds, insert a screwdriver, flick the latch, and you're indoors. That's crazy, right? Anyway, bringing it all together. We love Mr. Robot. Why? Because the hacks you see on Mr. Robot are real. And the reason they're real is they've actually got an ethical hacker or a security researcher, a bit like us, who advises the show. So the hacks you see there are based on reality, not like CSI Cyber, which is frankly made up rubbish. Anyway, in this particular episode, the hacker was tasked with increasing the temperature inside a storage vault in order to make some magnetic tape storage sublimate. So they had to fool the smart thermostat into getting too warm. In the episode, they did it with a Raspberry Pi. Cool, but we thought we could go one better. And we went through an exercise to do a first ever proof of concept of real ransomware running on an embedded system. Now, there was a funny tweet a few years ago that made me chuckle. It wasn't real, it was a joke, but I liked it. And we thought, let's go see if we can do that ourselves. We did this as a talk at DEF CON a few years ago. And what I love about this is you can do a lot of research without even having the product in your hands. Most products you'll find they're FCC regulated, so you go to the FCC website, you search for your product, you pull the interior photographs, and before you know it, you've got a PCB and you've got potential access vectors. Right-hand side, 6 pins, probable JTAG. It's worthwhile having a crack at this. We might be able to recover the firmware. Great, good place to go. Except that we didn't even need to have it because you could go to the manufacturer's website and they published their firmware. Winner, winner. So we downloaded it. Comes down as a binary blob as you'd expect. How do you turn those ones and zeros into a file system? Bin walk. Bin walk. A few minutes later, we had the file system. My amazing colleague, Andrew Tierney, follow him in on Twitter, Cyber Gibbons. He is amazing. He did all this work. We've got a file system. What did he discover? He discovered a copy command, CP. He discovered it wasn't validating for the input type. What was supposed to be happening is it was supposed to upload an image file and set it as a wallpaper on the thermostat so you could have family photographs on your wall. Great idea. It didn't check. It was an image file. we had arbitrary code execution at this point, which meant we had control straight away. Now, once we got in, we had the firmware out, and we started analyzing the firmware, and you wouldn't believe some of the crazy stuff we find. I think that a lot of firmware devs don't realize that people like us exist. So they think that code, once it's been compiled and distributed, will never be seen again. This thermostat, if it failed to create an SSL connection correctly, this was the code. The SSL shit status. Wow. And then you couldn't just, it wasn't just one photograph you could upload. You could actually upload 3 family photographs, and it wiped between the 3. And the code that dealt with the wiping was called the son of a bitch mode. Wow, I'm blown away. Anyway, so as a result, we successfully created the first ever proof of concept ransomware for a smart thermostat. The only thing we got wrong was the Bitcoin exchange rate. It went up a bit between us doing the project and actually publishing it. Yeah, $60,000 for a, anyway. What you're going to do is rip it off the wall and just short the terminals, right? But hey, this shouldn't have been possible. It should have been harder than this. It should not mean game over because you've given your product to the attacker. Now, nipping back to EV and IoT, there are laws coming, and you need to be aware of these. They are important. You should really pay attention. On EVs particularly, there's no regulation of charge point security right now, but as you probably know, you can get a grant to install a smart charger at home, and it covers way over half of the cost of the charger. If it's accredited under that, it must have appropriate security measures, except that all the chargers that we tested were accredited under the scheme. Oops. Now, in fairness, DFT listened. It's great. Government actually listened. Wow, fantastic. And they've got some new laws coming out. They're consulting on them right now to make security requirements mandatory for EV charge points. The bit that freaks me out is not the fact my car's not charged. It's not about my charger. It's about all the chargers acting as one. So instead of having one charger going off and on and pissing me off, all the chargers go on, all the chargers go off, all the chargers go on, and the grid falls over. Whoops. So one of the wonderful things that the Department for Transport are proposing is that when a charger starts, there's a random time delay. So even if the entire platform is hacked, hardware side, it waits a random time so we don't get these crazy spikes that take our grid down. Crazy, right? US, on charge points, there is a really interesting law that's just come in, which came in a couple of months ago, which talks about charge points as part of a much broader funding. But there is some interesting IoT legislation that will affect this, and I'm going to come back to it. So the IoT Cybersecurity Improvement Act is really interesting. It means that federal agencies cannot purchase vulnerable smart devices. So if you don't want to close off the US federal market, make sure your products are safe and secure. There's also some state regulations. So California Senate Bill 327 will come to, probably affects charge points too. And in the EU, I do hope everyone's paying attention to the EU Cybersecurity Act. The big key point here is the EU's already said that it's going to hang off ETSI 303645, which is a really good standard for building secure products. So if you don't follow that standard, you're crazy. It's a really good standard. It was built by a bunch of people I know. I contributed to it to a degree. It's also referenced in the PSTI bill, the Product Security Telecommunications Infrastructure Bill that was introduced to Parliament a couple of Mondays ago. So you can carry on if you like, building vulnerable product, or you can follow some great standards and future-proof that your product will go to market secure and safe. Anyway, I said I'd come back to Kayla. One thing I'm quite proud of is that the senator who introduced Senate Bill 327, which is the first law globally that made cybersecurity mandatory for consumers in the state of California, referenced our work on my friend Kayla. So that little dolly made a difference. Bring it on. Thank you. That is me. I'm on Twitter, on LinkedIn. There's loads on the blog about how to build IoT security. Hope you found it useful. Thank you.